Alrighty. To find the equation of the tangent line, you want to rewrite this equation as follows by just taking the power and dropping it out front. It's a property of logs you can do. Now to derive this, you just leave the 3 over 2 out. The derivative of ln u is u prime over u. So the derivative of x would be 1 over x. There's your derivative. Oh, maybe we should put derivative. That's my derivative. Now, to find the equation of the tangent line, I need to find the slope. I have my point. So to find the slope at this, I need to plug in 1. So when I plug in 1, I'm going to get 3 over 2 over 1 over 1. So you got 3 over 2. That's my slope. I have my slope. I have my coordinate. Could I find my equation? Yeah. I'm going to use this type of equation. Y minus y, so y minus 0, x and y, equals slope, which is 3 over 2, times x minus 1. Which you could also rewrite that, but we're just going to leave it like that. You could drop the 0, and you're done. You could distribute it, put it in slope-intercept form. You could change the forms around. Okay, but you're hopefully good enough to do that. But so you basically found the derivative, plugged in the 1, made your equation. Right. Again, the other way would be, looks like this. That'd be a point slope answer. That's also an okay answer. For number 48, if I want to derive this, it's just asking for you to derive it. This is actually a product rule. Now, could I take this x and bring it up here and make it x to the x power? Yeah, but that would make it really ugly. Now, if that began with an x to the x power here, you could take it and put it up front. Keep track of that. I do not want to move that up. I'm just going to leave it. I'm going to do product rule. So y prime, derivative of x is 1, leave ln x, plus leave x, and derive ln x. Well, ln x is 1 over x. So my derivative is ln x plus 1. Now, make sure you don't think that plus 1 is inside the ln x. If you want to, put this right here. It's your call. I think that could help. That is simply your answer. Not as hard as it might seem at first. 52 here, if I want to derive this, you don't want to deal with the quotient rule. I could do u prime over u, but I'm dealing with the quotient rule. It would be kind of a pain. You have to remember your properties of logs. I can rewrite this as the ln of 2x when you have a division that's minus ln x plus 3. That is so much nicer to use the properties of logs to rewrite it and then deal with your new piece. So if I want to derive this, it's actually not that difficult. U prime, what's the derivative of 2x? Well, that would be 2 over u, which is 2x, minus derivative of x plus 3 is 1 over x plus 3. Now, could I try to get a common denominator and so forth, if need be? Yeah. This is an okay answer. I mean, I'd probably cancel this off and make it a 1. I could get a common denominator. All right. Let's do the common denominator thing. This could be good, depending on the type of problem. But if I want to get a common denominator, I'm going to have to multiply this one by x plus 3. So this one's going to be x plus 3 over x times x plus 3. And this one's going to be x over x times x plus 3. Does that look right? Multiply this one by x over x. Multiply this one by x plus 3 over x plus 3. So my answer looks like it would probably be, combine the tops, x minus x. Wouldn't there be 3 on top? and the bottom would just be x times x plus 3. Now, why do we change this type of equation into this type? The premises of that is if you're trying to find a critical number, you need to set the bottom and top equal to 0, and this is a lot easier. What would your critical numbers be? 0 and negative 3? That's pretty. Okay.